Hello. Welcome once again. We are glad to have you with us on our series on engineering mechanics. Kindly subscribe, like, share, leave your comments and suggestions at the comment section also. Once again, welcome again to our series on basic mechanics. Today we are looking at analysis of trusses using method of joints. Analysis of trusses using method of joints. And using the method of joints, we can solve the problem using angles or using distances. In this question, we are going to solve our example using angles. And in the next video, we are going to solve using distances. Quickly, let's look at how to our question and how to go about it. Find the force in each member of the structure below. We have been given this structure and we are asked to find the force in each member. Don't forget that anytime you want to find the force in each member, then the appropriate method to use is using the method of joints. Let's see how to solve our question. Good. Anytime you are given question on trusses, the first thing you need to do is to draw your free body diagram. Now look at this side. Anytime you see this kind of support, this kind of support is a pin support. Anytime you see a circular, this one is circular. Anytime you see also something like a circle, small circles underneath, it means that the support there is either a ruler or a rocker. So in this case, we have a rocker. What you need to do is to detach the whole truss system from the support and you draw your free body diagram. Let's draw our free body diagram. Our free body diagram is going to look like this. This is from A to B. This point is A, this is B. This point is C, and then this point is D. This point here is D. This is B, this is C, and this is A. And then we have another point in between, and that point is E. This point is E. And we are saying that the support at A is a pin support. When you have a pin support, it means that you have two reactions. It is restricting motion in the X. Therefore, we call this AX. It also restricts motion in the Y, and we can call this AY. And then at B, we have a rocker. Looking at the way it is placed, it will allow us to move on the X-axis, but it will not allow us to move on the Y. Therefore, our reaction will be in the Y. So we can call this EY. And we have a force of 3 kilonewtons here. We have another force here, which is 5 kilonewtons. And then we have another force at E, which is 4 kilonewtons. And we are told that the angle here is 60. And the distance from this point to that point is 6 meters. This is 6 meters. This is 6 meters. This angle is also 60. Anytime you are given a question like this on trusses to analyze using the method of drawing or even the method of sectioning, the first thing you need to do is to determine the reactions at support or the external forces. These are the reactions at support. 1, 2, 3. These are the reactions at the support. That is the first thing we need to determine before we can even analyze the internal forces in the truss system. And how do we analyze these external forces here, which we don't know, or which we can also refer to as reactions at support? We can be able to determine them using the equations of equilibrium. Using the equations of equilibrium. This is a 2D body. We only have x-axis and y-axis. Therefore, our equilibrium equations will be only 3. We have sum of moment is equal to 0. Sum of all forces in the x is equal to 0. And sum of all forces in the y is equal to 0. We are going to use these equations to determine the external forces. But before we do that, let us try to get the height. Now we know the horizontal distances, but we don't know the vertical distance. Therefore, let's try to get the height. We know that this body is symmetric. This side is 6, this side is 6, and this side is 6. So it is symmetric. Therefore, if we are at this point, we can now trace it down here. And if from this point to that point is 6, then we can say that this line is divided into equal halves. This side will be 3 meters, and this side will also be 3 meters. Good. So the 6 can be divided into 2. It's the same for this side. It can also be divided into 2. This side will be 3 meters, 3 meters, and this side will also be 3 meters. We can also do same for this side. This side will be 3, this side will be 3. And from there, if this is 3 meters, and then we want the height, and this angle is 60, then using this angle and this side, we can be able to determine our height. We can say that 60 will be equal to the opposite over the adjacent, which is h over 3. And from there, we can say that our h will be equal to 3 times 60, and that will be equal to 5.2 meters. Good. Then once we are done with that, now we can be able to determine our external forces using our equations. Anytime you are given the force and you want to find the moment, take the moment at the point which has many forces. Now in this diagram, we can see that from this diagram, we can see that we have AS and then AY. And then at point A, we have 2 forces. At all the other areas, we have a single force. Therefore, the place to take our moment should be at A. At A. So we can say that taking moment at A, and we are taking our anti-clockwise direction to be positive. Taking moment at A, we can see that we have this force here, 3. It is a horizontal force. Therefore, the perpendicular distance will be a vertical distance because it's a horizontal force. Therefore, our distance will be from this point to that point, which is going to give us 3 times the distance from this to that, which you have seen that it is 5.2. 5.2. And we determine whether it will be clockwise or anti-clockwise. Now you can see that our force is applied here, and this is our distance, and this is where we are taking our moment. Now you can see that this force is going to rotate this side. If this side is fixed, this force is going to rotate this part in this direction like this. And now in this direction is a clockwise direction. It's a clockwise direction. Therefore, the whole of this will be negative minus, we pick this force here. It's a vertical force. It is 5. The distance, it is 5. And then because it's a vertical force, don't forget that moment is B times F. B times F. This is a vertical force. Therefore, the perpendicular distance will be from this point to where we are taking our moment, which will be a horizontal distance. And from this point to that point is 3 plus 3 plus 3, which is 9. So we are going to get 9 times our force, which is 5. But why are we getting the negative? Because if the force is applied in this direction, and this is where we are taking, this is the distance, the perpendicular distance, A, then we can see that this force is going to rotate this beam in this direction, which is also clockwise, and therefore it will be negative. And then we do the same for this 4 here. It's a vertical force. Therefore, the perpendicular distance will be a horizontal distance, which will be from this point to where we are taking our moment. And we have 3 plus 3 plus 3 plus 3, which is equal to 12. Therefore, we have 12, the distance times the force, which is 4. But we can also see that the force is applied downwards like this, and this is our distance. And this is where we are taking our moment. So it's also going to give us a clockwise movement. And it's going to give us minus. And then we have our EY, which is pointing up here. Our EY, which is pointing up. We are going to get, this is a vertical force. Therefore, the perpendicular distance will be from this point to that point, which is 6. Therefore, that will give us 6 times EY. And will it be clockwise or anti-clockwise? This is our distance, and our force is applied here. And this is where we are taking our moment. Therefore, this force is going to rotate the object in this direction, and this direction is anti-clockwise, which should be positive, and this will be equal to 0. And when you simplify from here, you can see that 6 EY will be equal to 108.6. And from there, we can see that our EY will be equal to 18.1 newtons. Then once we are done with that, we can also get for our AY. If we have gotten EY, we are left with AY and AX. We can use these other equilibrium equations, and we can say that sum of forces in the Y direction is equal to 0. And anytime you are moving, the force is moving up, it's positive. Therefore, we have this AY here is moving up, positive AY. We have EY also moving up, positive. EY is moving up, positive. And we have 5 coming down, minus 5. We have this 4 coming down, minus 4 is equal to 0. But EY we have calculated to be 18.1. Therefore, EY plus 18.1 minus 9 will be equal to 0. We can say that from here, AY will be equal to negative 9.1 kilonewtons. This is kilonewtons as well. We are left with AS. We can also say that sum of all forces in the X is equal to 0. We are taking this direction to be positive. Therefore, this force here is moving in the same direction as our positive axis. We have 3. And this force is moving in the opposite direction, minus AX is equal to 0. And from here, we can see that our AS is equal to 3 kilonewtons. Now, once we are done getting the external forces, we are now going to analyze the internal forces. How do we analyze the internal forces? What we are going to do now is that, because we said that in this question, we are going to solve using angles. We are going to solve using angles. Therefore, we need to get all angles in the diagram. We need to get all angles in the diagram. We are told that this is 60. And because we know that the whole thing is symmetric, so if this is 60, the length of this side is equal to the length of this side. So if this side is 60, then this side, this angle here will also be 60, and this angle will also be 60. But don't forget that we divided this side into 2, like this, 2 equal halves, and we said that this is 3, this side is also 3. Therefore, if this is 3, and this is 90, this is 90 degrees, this is 60, this is 90. It means that this angle here, when we divide, is going to be 30. And this side will also be 30, since this side is also 90. We know that angles in a triangle add up to 180. Therefore, 90 plus 60 plus 30 will be equal to 180. It will be the same for this side. If we try to divide this side, the angle here will be 60, since it is symmetric. This angle will also be 60. This angle will be 30, and this angle here will also be 30. The same applies to this side. This angle here will also be 60. The one up here will be 30, and the one this side will also be 30. Good. Then once we are done with that, now we need to indicate our directions using the Newton's third law of motion. Since each of the beams there are exerting a force on the boat at the joint. Therefore, from the Newton's third law of motion, we need to indicate our direction. If we take it that the force this boat is exerting on this member is moving this direction, then the one this boat is exerting on this same member here will move in the opposite direction like that. Will move in the opposite direction. If we take it that the force on the member here, if we take it that the force, we want to indicate the direction, always indicate your directions so that when you start solving it will be easier for you. If we take it that the boat is exerting a force on this member in this direction, then the boat here will exert in the opposite direction. If the boat is exerting at this direction on this, then the one at this side will move in the opposite direction like that. If this is moving that direction, then the one on this boat will be in the opposite direction. We can indicate for all the other members, opposite direction. If this one is moving this direction, then the one on this boat will be in the opposite direction according to the Newton's third law. Once we are done indicating our directions, then the next thing is to analyze the boats one after the other. We are going to separate, we are going to dismember the whole truss system and analyze each joint one after the other. However, take note, anytime you are analyzing, you should always start with the one with the maximum of 2 unknowns. Start with the joint with the maximum of 2 unknowns. Now, you can see that when you pick A, you don't know the force in this member here. You also don't know the force in this member here. Therefore, we have only 2 unknowns. But when you pick the one at B, 3 members are meeting at point B, and all the 3 members are not known. Therefore, we have 3 unknowns at B. And so we cannot analyze B, but we can analyze A, since A only have 2 unknowns. Therefore, let's pick A and start to analyze. This is our joint A. And then we know that at A, from our free body diagram, we have AX going that direction. We have calculated AS to be 3 kilonewtons. We have AY. We have AY being negative. When we calculated AY, it was negative. Therefore, it means that our direction we indicated here was not right. It was supposed to move down, which we can indicate as 9.1. Which we can indicate as 9.1. Or yes, so we can even decide to 9.1. That would be okay. Then we have this member at this side, this member at this side. Said that this will move this direction, this will be in the opposite. If this is going this direction, then the other will be in the opposite. So the member moving here is moving in this direction, and it is from A to P. So we can call the force there as FAE. And then the member from this point to that point is moving from A to B. We can also refer to that force as F. It's moving this direction as FAB. FAB. From here, we can see that this force here is in the X, this is in the X, this is in the Y, but this is not in the X, this is not in the X nor the Y. And we need to resolve into components. We need to resolve into components. Therefore, we can resolve that if this is our horizontal axis, the angle this AB is making with the horizontal is 60. So we have our 60 degrees here. And from there, we can resolve into x and y component. X and y component. You can see that here, this is the direction of our force. Therefore, we are starting from this point and ending at that point. Therefore, on the x, we are going to move this direction like this. Don't forget that our directions are like this. When we are moving, this direction is positive, this direction is negative, this direction is positive, this direction is negative. So you can see that we are moving this direction on the x, which is going to be positive, and then we'll be moving up on the y, which will also be positive. Resolving will give us, we know that the s side is adjacent to the angle. Therefore, it will give us FAB cos 60, and our y side is opposite the angle. Our y side is opposite the angle, which will give us FAB sine 60. So from there, we can use our equilibrium equations to get the unknowns. We can say that sum of x is equal to 0 and sum of y is equal to 0. Let's use sum of y is equal to 0 first. When we are moving up, is positive. Sum of y is equal to 0 is going to give us, sum of y is equal to 0 is going to give us, the 9.1 is coming down, therefore negative 9.1. And then we have the y component for this force here, which we said is FAB sine 60. That will give us plus FAB sine 60 equals 0. And from here we can see that FAB will be equal to 9.1 over sine 60. And from there, FAB will be equal to 10.5 kilonewtons. Good. 10.5 kilonewtons. Allow me to erase this side so that we can continue with our analysis. Good. Now we have been able to calculate FAB. I've been able to calculate FAB. And we are getting FAB to be equal to FAB is equal to 10.5 kN. Now we can write the equation for x. We can write the equation for x. Sum of all x is equal to 0. And for x, we can see that we have this x component here, which is for ax. And we know that ax is equal to 3. But look at the direction. It is moving in the negative side of our axis. Therefore, it will give us negative 3 plus. We have FAE, this horizontal force. This horizontal force is moving in the positive direction. We have FAE, and then the horizontal component of this force, which we said that it will be FAB cos 60 is equal to 0. And from there, if you do the analysis and you have FAB already, therefore substitute the value of FAB into the equation, which will be negative 3 plus FAE plus FAB, which is 10.5 cos 60 is equal to 0. So from here, if you do the change of subject and you calculate FAE, we are going to get the value of FAE to be negative 2.25 kilonewtons. We are done analyzing joint A. We move on to the next joint. Don't forget that we have stated that analyze the joint to the maximum of 2 unknowns. Now you can see that we have been able to determine the force in AB. Therefore, when we come to joint B, we know the force in AB, but we don't know the force from A to E, from B to E, and we don't also know the force from B to C. Therefore, we only have 2 unknowns, and now we can analyze joint B. Joint B, we have a horizontal force here, which is 3 newtons. We have another horizontal force moving from B to C. Therefore, we can call it force F. We can call it as force FBC. FBC. And then we have the one from B to A is the same as A to B. It's the same as A to B. Therefore, we can call it as, it's the same as, from B to A is the same as A to B. So there's no need of changing the name. We can still maintain it as FAB, which we had already calculated. And then we have the one from B to E. And we can also call it, we are following the directions which we have already indicated. This is FBE. And from here, we can resolve the ones which are not in the S and Y into components. We resolve this into components, and you can see that our angle which FAB from, this is FAB, at B, it makes an angle of 30 with the vertical, and this side also make an angle of 30 with the vertical. Therefore, here we have 30 at this side, 30 degrees, and we also have 30 at this side, 30 degrees. And from there, we can resolve. This is where we are starting from, and we want to get to this point. So you can see that we'll be moving down on Y. We'll be moving down on Y. We'll be moving down on Y. Therefore, our Y component is going to be negative. Our Y component is negative, and from there, we're moving this direction on the X also. Therefore, that component will also be negative. Our S component for FAB will be negative. And the angle is 30. You can see that the 30 is facing our S component. Therefore, our S component for FAB will be equal to FAB, negative FAB. The angle is facing that side, sine 30, sine 30. And then our S component, our Y component for F, the force at this side. You can see that our Y component is adjacent to the angle 30. Therefore, we are going to get negative FAB times. It's adjacent to the angle, therefore it will give us cos 30. Cos 30. FAB cos 30. You can also resolve the force here into component. You can see that the force here, I'm talking about FBE. FBE, we are starting from this point and coming down here. Therefore, you can see that Y also will be coming down. Therefore, our Y component there is going to be negative FBE. But look at our Y, it's adjacent to the angle 30 here. It's adjacent to the angle 30. Therefore, it will give us cos 30. And then we can also see that the S component will be moving this direction, and this direction will be positive. Therefore, you are going to get FBE sine. Don't forget that the side is facing the angle, so sine 30, sine 30. And from here, we can apply our equilibrium equations. Sum of all f of y is equal to 0. Let's put all the y together. Here, we only have y component for this side and y component for this side, which will give us negative FAB cos 30, and this side also negative FBA cos 30 equals 0. As we have already calculated FAB, our FAB is 10.5. Therefore, negative 10.5 cos 30, and cos 30 is 0.5. 0.5 minus 0.5 cos times FBE. Cos 30 0.5 is equal to 0. And from here we can calculate FBE. Our FBE will be equal to 9. Sorry, cos 30 is not 0.5. Cos 30 is 0.866. cos 30 is 0.866. 0.866, and cos 30 here will also be 0.866. So from here, we can see that our FBE will be equal to 9 over negative 0.866. And from there, we can be able to determine the value of FBE. We can be able to determine the value of FBE. Allow me to erase this, and then we can continue from there. Therefore, our FBE, the value of FBE will be equal to negative 10.5 kilonewtons. We can also write our equilibrium equation for x is equal to 0. Don't forget that direction of this is positive. On the x, we know that this 3 newtons is moving this direction. It's in the same direction with our positive x-axis. Therefore, we are going to get 3 plus our FBC is also in the same direction with our positive x. That will give us FBC. And then we have our f, which was moving this direction. And then we said that it's negative FAB sine 30. And then our f for this side, which was positive, FBE sine 30 is equal to 0. We know FAB, we know FB. We can put the values in there. And from there, we are going to get 3 plus FBC minus FB is 10.5. So 10.5 times 0.5. And FBE is now negative 10.5, which will give us plus negative 10.5 times sine 30, which is 0.5, is equal to 0. And from there, our FBC will be equal to 7.5 kilonewtons. Now we have gotten the value of FBC equals 7.5, and then we have also gotten the value of FBE to be equal to 10.5. I want to clean all the space there so that we can get a wider view of what I'm trying to explain. Now from there, we can move on to our next joint and then analyze the next joint Don't forget that we said that you should always analyze the joint with a maximum of 2 unknowns. Let's see the next joint which we can go to. Now, when we come to B, when we come to E, we have calculated this side. We have also calculated, AE. We have AE. We know the force in AE. We have also calculated BE. So we know the force in B. We are just left with the force in B, in EC, and ED. We have only 2 unknowns. Therefore, we can analyze joint A. We have a horizontal force this direction, and that one is FAE, and you have calculated FAE to be negative 2.25. But our direction, our force is moving in this direction. Considering this direction we have indicated here, it's going that direction. And then this one here is going to go that direction. Our FED, this is force FED, moving that direction. And then we have our force moving up here. This force is FEC. And we also have another force from E to B, and we have already calculated that. So we can call it FBE, moving that direction. So we need to resolve this force and that force into components. And we know that the angle it is making with the horizontal is 30 and the angle it's making with the vertical is 30. Therefore, we can just draw our axis like this. This side is 30, but this side is 60. This side is 30. And this side is what we are indicating, and that side is 60. So from here, we can resolve our force. We can resolve our force into X and Y component. Using the 60 degrees here, our S component, look, we want to move from this point to that point. Therefore, our S component is going to be in our positive X. We are going to move in the direction of our positive X, and then we move up. So both X and Y will be positive. Therefore, the S component using this angle, the S component is adjacent to the angle 60. Therefore, it is going to give us FEC, because it's adjacent to the 60, we are going to get cos 60, and our Y component is going to be FEC. It is opposite to our angle. We are going to get sine 60. And then it is going to, we go to this direction, we also resolve the one going this direction. Using the angle 60 there, the S component is also adjacent to the angle, therefore we can get it as FDE. But look at it, you'll be moving in the opposite direction. If you want to move from this point to that point, you'll be moving in the opposite direction to our positive x-axis. Therefore, our x will be negative FDE cos 60, and then the Y component will be moving up, which will be positive. Therefore, it will be FDE sine 60. And from here, we can just put our sum of all Y is equal to 0 and sum of X is equal to 0. So sum of Y is equal to 0. Don't forget that when you are moving up, it's positive. We only have two Y components, one for this force here and another for this. The one for this is positive. We have FEC sine 60, and then we have the one for this side, which is FDE sine 60 is equal to 0. Now we have, don't forget that at E, we also have a reaction. We have a reaction there. We have a reaction down there. So we have our reaction is down here. And it is going up, which is 18.1. Therefore, plus. This force is moving up, which is 18.1 is equal to 0. It's equal to 0. And from here, we have already calculated our FDE. Our FDE is 10.5. Therefore, we are going to get FEC sine 60 will be equal to negative 18.1 minus 10.5 times 0.5. 10.5 minus 0.5. Good. Our FDE, which we calculated, don't forget that our FDE was negative. Sorry for that, our FDE was negative. So it's negative here, but if it crosses the equal sign now, it becomes positive. Therefore, we are going to get FEC is equal to negative 9 over sine 60. And that is going to give us negative 10.4 kilonewtons. Then we can also use our x. Sum of x is equal to 0. And from there, we are going to sum all the x. We have this s going this direction, and it was negative 2.25. And we are moving in the negative direction of our x. We are moving in the negative direction of our x. Therefore, we are going to get negative 2.25. Don't forget, if you get negative answer, use the negative answer to work throughout and maintain your directions, which you had already indicated. Negative 2.5 plus FED, which is the force here, FED, plus horizontal component for this, which is FEC for 60, plus horizontal component for this, which is negative FDE cos 60, and from is equal to 0, and from there we are going to get an answer to positive 2.25 plus FED. We had already calculated FEC from here. So we have FED. FED good. We have our FED and then we have already calculated FEC to be negative 10. So we have negative 10.4 times cos 60. And then FB we have already calculated as negative 10.5 cos 60. Cos 60 equals 0. And from there, when you simplify, your FED will be equal to negative 2.25 kilonewtons. So we have analyzed 3 of them. Now we have FEC equals negative 10.4, and then we have FED equals negative 2.25. So from here we go to the last joint, because we are going to, there are 5 joints, but once we will be done with the 4th joint, all of the members, the forces in all of the members would have been known, and we would have finished with our problem. So quickly, let's look at the last joint. We can either analyze joint D or joint C. Each of them will give us the same answer, but for the sake of, I think the D, we only have 2 members, so the D will be easy. This is D. We have a force which is going that direction, and that one is force ED. And then we have a force coming down like this, which is 4 kilonewtons. And then we have this one from B to C, which we have already labeled as FDC. And we said that it's going up. So from here, we can resolve this force here into components. If this angle here is 60, then if you want to move from this to that, you can see that we move up on Y. So Y will be positive, which will be FDC, and Y is facing the angle, therefore sine 60. And our S component, we are going to move this direction, which will be negative FDC cos is adjacent to the angle, cos 60. And from there, we resolve sum of all f of x is equal to 0. So we can say that negative, look at FD is going this opposite direction, FED is going the opposite direction. So we have negative FED minus FDC cos 60 is equal to 0. But we have already calculated FED, which is negative 2.5. So therefore, negative 2.25 minus FDC cos 60 is equal to 0. And from there, you find out that our FDC, when you simplify, our FDC will be equal to 4.5 kilonewtons. 4.5 kilonewtons. And we have already calculated FDC. Now you can see that we have the forces in all the members. Therefore, you can use the Y components to check the validity of your answer. You can see that sum of f of Y is equal to 0. And from there, we are saying that we have, we can see that we have 4, which is pointing downwards. 4 is pointing downwards. Therefore, negative 4 plus FEC sine 60 is equal to 0. So you are going to get negative 4 plus, you have calculated FEC to be 4.5 times sine 60, and sine 60 is sine 60 will give us, I think, this is 0.5 sine 60. Good. Sine 60, which will be 0.866. 0.866. And when you do that calculation, you find out that we are very close to this, and that is giving us something which is very close to 0. So we can see that our solution is right. You can see that 4.5 times 0.866 is going to give us negative 4 plus 3.897. We are getting that because of the approximations we made, which is approximately, this is approximately equal to 0. So our calculations are right, and we are done solving this question. It's very easy, just that you have to do a lot of calculations and a lot of analysis, but it's very simple. However, if you have any question or any problem, you can let us know, and we'll be glad to assist you in understanding the concept. Leave your comments and your suggestions at the comment section. Thanks once again for watching. Kindly subscribe to our channel and hit the notification bell as well. See you in our next video, where we'll be solving using distances. Bye-bye.